Hi, I'm Matt Fitzgerald, Principal Technical Evangelist at Amazon Web Services, and we are going to be talking about event-driven service architecture with Amazon EventBridge. EventBridge is a new event bus service that makes it easy to ingest and process data across AWS and SAS applications. EventBridge removes the friction of writing point-to-point integrations by letting you easily access changes in data that occur in AWS, custom, and SAS applications via a highly scalable central stream of events. With EventBridge, you get a simple programming model where event publishers are decoupled from event subscribers, allowing you to build loosely coupled, independently scaled, and highly reusable event-driven applications. Lastly, it's fully managed. So it handles everything from event ingestion, delivery, to security, authorization, and error handling. It's serverless, so no more managing infrastructure and building event bridges on top of it. If you've ever been to an AWS conference before, you've probably seen a slide like this. But I'm here to tell you that monoliths get a bad rap. Monoliths are easy to build and reason about. It's way simpler to understand how the system is going to work when all of your data is in one ASIC compliant database and all of the calls you're making are operating against the same memory address space. Distributed systems of microservices are way more complex, but the problem is monoliths don't scale, both in terms of throughput as well as in the teams that support them. If you have big complex systems and you want to be able to effectively leverage dozens or hundreds of engineers to build features in parallel, you have to move to the microservices model, which gives you more customers. Lastly, we want to be able to do it way. You saw in Gabe's session, he talked about orchestration versus choreography. Gabe used AWS step functions to choreograph all of the various components that were required in order to create a bank account. Without step functions, if we wanted to use a purely event-driven architecture, we have to have some kind of event bus that events would transit along. The events would then need to have some kind of logic wrapped around them so we would know what to do with them and in what order. This session is not about orchestration. This is about extending that banking system for other purposes. So we talked about an event bus. Well, what kind of event bus? So we've got the banking application on the left-hand side, and then we have some microservices that we may want to use to augment the functionality of the banking application. Enter EventBridge. The banking application is a separate entity owned by a separate team. It is also perhaps a microservices architected system, in which we know it is because Gabe showed us, but its services are orchestrated differently, in this case with step functions, which we previously mentioned. So how do we enable other teams within the bank to take advantage of this system? Now, before we go too far down the track of working in a purely 100% Amazon EventBridge architecture, there may be situations where the system you want to integrate with isn't putting events onto an Amazon EventBridge event bus. In cases like this, you may have to poll the system, perhaps look at event logs or other metrics that you can use to infer events. You would then use a Lambda function to put those inferred events onto the event bus so downstream systems can take advantage of them. We won't be focusing on that in this session. So let's focus a little bit on the naming side of things. So in traditional enterprise service buses, they use terminology like emitters, agents, channels, consumers, and sinks. Remember, emitters and agents are the things that actually create the events. In Amazon EventBridge, these are known as sources. The channel is the event bus. The channel is the thing that transits all of the events that arrive from the sources. In the traditional model, we also had consumers and sinks. Event sinks and event consumers were simply other components that would subscribe to the event bus and take some action when the event came in. With EventBridge, these are called targets. So let's look at the basics of Amazon EventBridge. All the components of Amazon EventBridge are boxed here in pink. You see that we have a default event bus, some custom event bus, and there's some event bus associated with SAS integrations as well. And we have the rules and targets on the right-hand side. We also have sources. These are the sources of events that will end up on the event bus. Event sources could be other AWS services, custom applications. In our case, it's going to be the banking application. And we just talked about the SaaS applications that can be integrated to Amazon EventBridge. We have the event buses themselves. By default, EventBridge gives us a single event bus called default. We'll create a custom event bus for our demo banking application. We're not going to be focusing on event buses that are required for SAS integrations, but be aware that they do exist. We have the rules. The rules are essentially patterns that are going to be used to match events with target actions, which is a great segue for event targets. An event target could be a Lambda function, could be a Kinesis data pipeline. It could be kicking off another AWS step functions workflow. Here's an example of the event structure. We have a detail type, which is an analog to an event category. We have the source telling us where that event has come from. And then we have detail. Detail is really just a collection of key value pairs that further describe the event. Now we know what events look like, and they're very simple. There's really not much to an event. We'll have a look at the rules and how the rules are used to trigger our targets. So let's just have a look at this event. So we've got an example here around application approved. We'll see that the source of the event has come from a DynamoDB streaming table. The detail of the event is really describing an application-specific construct, which in the case is a bank account from Gabe's application. We'll see that the detail describes the name of the account application. We have a unique identifier for that application, and then we also have the state of that application. Then we have an example rule that's being configured. Now, if you notice, rules pretty much just look like the events, but a subset. And in this case, the detail type is application approved. And within the detail block itself, we also have state approved, and approval type is auto and human. So how is this actually matched? Well, if all of the items in the rule match what's in the event, then the target will be triggered. Here's another example. In this case, the rule is simply saying, if the inbound event has a detail type of application flags for review, then we'll trigger our target. So it's pretty simple how we map a rule to an inbound event. What about this one? So in this case, the event looks pretty normal. We have an application rejected detail type, but in this case, the example rule isn't matched. A particular inbound event, if nothing matches in the rule, that is, then the event is simply dropped from the event bus. We don't do anything with it. So what does this mean? Okay, so we've got event buses, we've got rules, we've got targets. We're able to match inbound events with those rule patterns. We're able to trigger targets in response to those rules matching. This allows us to essentially connect data from other applications, be it AWS services, our own custom applications, which we just saw, which is the banking application, and those SaaS applications. We can take data from those systems and we can integrate them into other downstream systems. But we do it by writing way less code. We can ingest, filter, and deliver events without writing any custom code, which reduces our operational overhead. And also, we talked about at the very start that this is a serverless solution, so we don't need to provision any instances or any other kind of software to get up and running with EventBridge, which ultimately leads us to being able to build event-driven architectures with ease. So some common use cases, obviously taking action. So a certain event comes in from an upstream system. We can match that event with a rule. We can then use AWS Lambda to maybe call off some other, application function to take some action. We can run workflows as well. So we saw that Gabe had orchestrated his components using AWS step functions. So I could also use the events coming from Gabe's components, create a rule that will match those events, but instead of calling a Lambda function, I can trigger the execution of another step functions workflow. I could even push events into something like SageMaker or Amazon Comprehend in order to do some kind of intelligence. I can use Athena to query over the events as well. So rather than taking the events from EventBridge and say kicking off AWS step function synchronizing data as well. So I can have DynamoDB being my target, where the Lambda function will process the event, put it into DynamoDB, and then we're able to keep systems like the upstream system, which is the event source, in sync with the downstream system. So let's dive a little deeper into the mechanics of Amazon EventBridge. The first thing we're going to need to do is create the event bus. This is something we're not going to need to be doing all of the time. So we're not going to show how to programmatically create it here. If you wish to do that, the API call on the EventBridge client is simply create event bus. But we're going to show it using the AWS CLI. So the CLI is an easy way to get working with Amazon EventBridge. So in this case, Amazon Events create event bus command. We're going to pass a name that will be used for that event bus. And in this case, we're going to call it Banking Demo Events Dev. So if you run that, that's all that's required to create a new event bus for Amazon EventBridge. Step number 2, we're going to need to create some rules. Now, if you cast your mind back a few slides, you'll see that a rule is effectively a subset of an event. Right? So it's a JSON structured object that consists of various key value pairs that you're going to be looking for in the event. So just like an event bus, creating rules is not something you're going to want to do programmatically on a frequent basis. So we're going to show how to create the rule using the AWS command line interface. Very similar to creating an event bus, we use the AWS Events put rule command. Now, for a rule, we need to specify a name. In this case, we're going to call the rule application submitted. We need to specify the name of the event bus that the rule is going to be associated with, which in this case, if you have keen eyes, it is not the same event bus as we created on the previous slide. In fact, in this case, it's going to be banking demo events. So banking demo events will be the event bus that the pattern is simply saying, if I see application submitted as the detail type in the source event, then my rule will fire. And lastly, we're going to enable the rule. If we don't enable the rule and the event comes in, then obviously we're not going to invoke any downstream Lambda function or step function and so on. Once we've created the rule, then we need to associate a target with that rule. Now, in our banking application, the kinds of integrations we're working with are simply going to be Lambda functions in response to some event. So in this case, we're going to, once again, use the AWS command line interface to create our event targets. So we use AWS Events put targets. We specify the rule that the target is going to be associated with. We specify the event bus name. Here we are actually using the correct event bus name, which is Banking Demo Events Dev. And we specify the targets that will be associated, the physical or tangible targets that will be associated with the rule. So in this case, it is going to simply be the ARN of a particular Lambda function, which is actually going to be How do we go about getting the events onto the bus? Well, we have a method on the EventBridge client for that called put events. Put events takes a single argument, entries. Now, what is entries? Entries is simply an array of no more than 10 events. Now we know what events are because we talked about them previously. That's that JSON payload that describes the event, essentially. So we can have up to 10 of those in the entries array, and we pass that array to the put events API call. What that does, puts the events onto the event bus. A couple of things to keep in mind though. Because you're passing in an array, there are some occasions that not all events will be put onto the bus. So it's important to check the response object of the put events call. Now here's an example of what the response object looks like. So the response object obviously has the entries, has an array itself called entries, which gives you the status of each one of those items in the entries array that you pass to put events. So you can iterate through that array to see whether any of those events failed to be submitted to the event bus. Obviously, you don't have to iterate through those entries straight away. You could simply check the failed entry count number, and if that was 0, then you can assume that all of those events were successfully put onto the event bus. The other thing to keep in mind with EventBridge is that it's at least once delivery. So you need to make sure you deal with item potency. And by that, I mean, you may have duplicate events describing the same thing going on the event bus. So you don't want to, you don't want to make sure, you don't want to allow that redundancy to have some kind of undesired impact further downstream in your event processing pipeline. So that's how we publish the events. The other thing we have to make sure we do from a security side of things is to give Amazon EventBridge permission to invoke those Lambda functions. We do that by creating a role. We essentially say, okay, so I'm giving Amazon EventBridge, which is denoted by the service, the principal service, events.amazonaws.com. We're going to give that permission to assume that role. And then the policy of that role itself is basically saying you can invoke the Lambda function, right? So fairly straightforward. But without this, what you end up getting is the rules will be matching. Well, EventBridge will be matching the rule patterns. But if you haven't given EventBridge the permission to invoke the Lambda function, then really nothing is going to happen with the matching of those rules. So make sure that you do set up the appropriate policies for EventBridge. So the key limits we need to be aware of when working with EventBridge. So per AWS account, you can have no more than 100 event buses. There is a limit in terms of the number of put requests per second, and that is currently 400. However, remember, each put request, which is put events, can put an array of up to 10 events per request. So keep that in mind. So, theoretically, you can put 4,000 events on the event bus per second. 2048 characters roughly is the upper limit for the maximum event pattern size. We can have 750 target invocations per second. Per event bus, you can have 100 rules, and for each one of those rules, you can associate up to 5 targets. So they are the key limits that you. Let's have a look at EventBridge from the context of the AWS console. So here's the event buses page. You'll see the default event bus that we talked about earlier on. This is always going to be there whether you're using EventBridge or not. And you can see our banking demo event dev event bus that we created earlier on with the AWS command line interface. Okay, so here's the example of EventBridge rule. So here's the application approve rule that we also created earlier with the command line interface. Note the rule name, application approved. The status of the rule is enabled, which means that if any events come in to match that, any targets, and you see at the bottom here, we see that we have the Lambda target associated with that rule. So as I said, if any events come in that match this pattern, in this case, the pattern is saying, if my detail type key is application approved, I'm going to run that function, that target function, which is the bank account service function shown at the bottom there. So really, this is how you can go into the console, play around with things. You can configure everything that I've just done from the command line interface using the console. Now, if you find you set everything up, you've created your bus, you've created your rules, you've associated targets with your rules. It's all good. You're publishing events. You think everything's all good, but nothing is happening. Now, we talked about security earlier on. Security is probably the first thing that you should go to if you're having problems with target functions not running or step function workflows not being kicked off and so on. But what I like to do is go into the console for CloudWatch metrics and just turn on my event buses that I have configured just to see whether we have any failed invocations. Because if you see failed invocations, it usually means that there's the rule is matching, but there's something wrong with the target. In our case, for the banking application, we're not able to invoke that Lambda function, which, as I said, usually means you've probably got something set up. Either the ARN of that Lambda function is incorrect, or there could be a bug in the configuring the aspect of your security. There probably may not be a bug in your Lambda function itself, because if the Lambda function exists and security has been set up, the Lambda function will actually fire. So from the EventBridge perspective, the invocation was successful. So you should also check CloudWatch logs as well to make sure that the Lambda function associated with the target isn't actually running. If you see an item in there that denotes that function has been initiated, then from EventBridge perspective, the invocation was considered successful. So if we look at EventBridge in the real world, so obviously we have Datadog. Now we're actually going to be looking at sort of two SAS integrations. SAS integrations are a really popular use case for Amazon EventBridge. So in this case, Datadog was enabling ticket prioritization and routing with the Zendesk EventBridge integration. So what does this mean? So the Datadog Zendesk customer experience platform generates events, and obviously for their customers, they want to be able to do things with those events like further downstream processing. So what they used is the EventBridge integration for Zendesk. When anything happens in Zendesk now, it generates an alert or an event. It goes onto the EventBridge, and then they can do further downstream processing for their customers. In this particular case, obviously, we're looking at faster case resolution. So now, that's all very great, but there's huge benefits from this. One, they have more timely response to event activity. Engineers are spending, time solving actual customer issues rather than managing various integration and point-to-point APIs. And because we're not polling the Zendesk system, they're not hitting their APIs as hard as what would have been done in one of those traditional point-to-point integration solutions. Cox Automotive, I've also been doing something similar in the incident resolution space. So they've got faster incident mean time to resolution with the PagerDuty EventBridge integration. So with this the SAS integration that we talked about right at the beginning of the session. So if you do want to learn more about Amazon EventBridge, I highly recommend the Intro to Event-Driven Architectures and Amazon EventBridge, which is on YouTube. It's about an hour long. It's fairly easy watching. Obviously, we have the EventBridge developer guides and frequently asked questions on the AWS homepage. So definitely check out those links to get started with EventBridge. Now, if you want to further or kickstart your modern application development journey, I highly recommend you have a look at the offerings from AWS Training and Certification. So we have training around developing on AWS. We have some certifications for DevOps engineer, as well as certified developer. So definitely, if you want to be relevant in the world of cloud computing, have a look at those. Have a look at those offerings. In addition to those links I mentioned earlier about getting started with EventBridge, and you'll be well on your way to modern application development, especially in the realm of event-driven architectures. So on behalf of Shaun, Gabe, and myself, I'd like to thank you for attending our 3-part session on modern application development. We hope you found it interesting. A kind reminder is that we would love you to complete the survey. Let us know what you thought of today's event, how we can improve the event experience for you in the future. So yes, definitely complete the survey. But we've had a lot of fun delivering or creating the content for the session and delivering this session. We hope you get a lot out of it.